let's move on to the question number 4. Given the confusion matrix, find classification accuracy, precision, recall, type error 1, type error 2, F1 score, sensitivity, specificity. Explain the importance of precision and recall as compared to accuracy with an example. So let's start with the question number 4. Here we go. What is confusion matrix? Confusion matrix is a table that compares the model's predictions with the actual results. It helps us see where the model is correct and where it makes mistakes. Here what each term means. True positive, model correctly predicts positive. True negative, model correctly predicts negative. False positive is model predicts positive but actually is negative. This is the type 1 error. False negative, model predicts negative but actual is positive, and this is type 2 error. Here we have four types of terms which we have seen. Moving on to the accuracy. Accuracy tells us how many predictions the model got right out of all predictions, but it can be misleading with when one class is much larger than the other. The precision tells us out all the positive predictions made by model, how many were actually positive. It is important when we want to reduce false positives like spam detection and fraud detection. Recall tell us out of all the actual positive cases how many models successfully detected. It is extremely important when missing a positive case is dangerous, like in medicine tests and like in medical deaths and the table which we make of the patients and who have taken the medicines or not. Moving on to the F1 score. F1 score combines precision and recall into single value. It is especially useful when the dataset is imbalanced and both false positive and false negative matters. Specificity is another important metric in the evaluation of classification models, particularly in the binary classification. It measures the ability of a model to correctly identify negative instances. Specificity is also known as the true negative rate formula. It is given by Tn upon Tn plus Fp. And let's see the formulas of everything once again. The accuracy is given by Tp plus Tn upon by Tp plus Tn up into Fp into plus Fn. Sorry, I said into. It's all plus, you can see on the screen. Precision is calculated by Tp upon by Tp plus Fp. Recall is calculated upon Tp plus Fn. And let's moving on to the F1 score. F1 precision and recall into a single matrices to balance their trade-off. It provides a better sense of models overall performance, particularly for imbalanced data sets. It is helpful when both false positive and false negative are important, though it assumes precision and recall are equally important, but in some situations one might matter more than the other. F1 score, it is calculated by 2 into precision into recall upon precision plus recall. So moving on to the specificity. Specificity is another important matrices that we have already seen. It is calculated by Tn upon Tn plus F1 Fp. Moving on to the type 1 and type 2 error. Type 1 error occurs when the model incorrectly predicts a positive instance, but the actual instance is negative. This is known as a false positive. Type 1 error affects the precision of a model which measures the accuracy of positive predictions. So type 1 error, also called false positive, happens when the model predicts positive but the actual case is negative. And type 2 error, also called as false negative, happens when the model predicts negative but the actual case is positive. So here are the formulas for it. Error 1 Fp upon my Fp plus Tn, and error 2 is Fn upon my Tp plus Fn. We have seen the example and the formulas and the definitions of all kind of terms. Moving on to an example, a diagnosis test is used to detect a particular disease in patients. False positive, this case predicts type 1 error. So type 1 error means the test says the patient has diseases, but they are actually healthy. And type 2 error means the test says the patient is healthy, but they actually have some disease. So let's take a cancer model example. Let's say 100 patient were tested, 10 actually have cancer and 90 don't. The model detects 7 correctly and positive and misses 3. These are false negatives. It also falsely predicts 20 healthy positive people as having cancer. These are false positive and it is correctly identifies 70 healthy people. So accuracy of this model is 77%, which looks good, but precision is only 25 because many positive precision are wrong, and recall is 70%, which means the model still misses 30% real cancer patients. So we can see this assignment question here. We have accuracy TP plus TN upon FP plus FN plus TP upon N. So the TP plus TN is equal to 14 by 20, so that by 10. Accuracy measures the overall connection of the model, that is the proportion of our prediction that are correct. So 70% prediction are correct. And you can we have I have already said it. We can see it here. 75% is correct and 25% is not correct. So the only 60% of positive are captured. So summary is that accuracy alone can hide real performance, and low precision means many false alarms. Low recall means missing real positive cases. Always look at both precision and recall, especially the sensitive application like fraud detection and medical diagnosis. I hope this explanation and the answers of these questions help you a lot, and it is not more confusing if we solve it by metrics. I've also provided the uh, formulas and the examples very clearly in the PPT. You can check it out. Thank you so much, guys. Let's move on to the question number 5th in next video.